In today's note, we are going to look still at solving quadratics or finding the solutions, but we're going to look specifically at one method of doing that called the quadratic formula. So let's just kind of review and solve the following equations. So basically we're trying to solve for x. So again, we want to set y equal to 0 because the solutions are the x-intercepts or the roots. So I want to find when x or when y equals 0. So I need to factor this. This is a simple trinomial, product and sum. Two numbers that multiply to 12 and add to 8. So my two factors are 6 and 2. Because 6 times 2 equals 12. 6 plus 2 equals 8. So that means when I factor, I get x plus 6 and x plus 2. Again, once we factor them, we set them equal to 0 and solve each part. So the first one is x equal negative 6 and x equals negative 2. So those are my two solutions. If I have something like in B, that's not in standard form but more in vertex form, I can still solve for x. It's just going to take me a few different steps. So let's treat this like a simple or a standard algebra question. If I want to get x by itself, I need to move everything over to the separate or to the other side. In this case, I want to get rid of the minus 5 by dividing both sides by negative 5. One side cancels out. I get x plus 3 squared equals 20. Now, if I want to get x by itself, I need to take care of this squared. So how do I take care or get rid of this squared? And the way you do that is by square rooting, because square rooting is the opposite of squaring. So when you square root, you basically cancel out the squares, but you got to do it to the other side as well. So here we have x plus 3 equals the square root of 20. Now, to get x by itself, I need to minus 3. So I get x equals minus 3 plus the square root of 20. Now, usually we're used to having two answers. Right? If we look back at our previous example, we're used to having two answers for our factored, or from our factored form. But in this case, I only seem to have one. We have to keep in mind, though, that the solution to any square root is actually two values. If I want to find the exact value, square root of 20, square root of 20 equals, say, 4.47 rounded. But we should know that from squaring things, it could be either positive 4.47 or negative 4.47. So what this actually means is that I have two possible answers from this square root. So x actually equals negative 3 plus or minus whatever the square root of 20 is. Just from the general understanding that when I square something, it could be positive or negative, and it would end up at the same value. Because basically the square root of 20 is saying that it'd be 4.47 squared, but it could also be negative 4.47 squared. So we do get two answers here. X equals negative 3 plus or minus the square root of 20. So this is another situation that you could come across where you have to find your two roots as well. If we look at C, C is a simple trinomial. It's set equal to 0 already. So again, let's look for the product and sum. So we're looking for two numbers that multiply to negative 7, but add to negative 2. And if we think about the factors, well, 7 is a prime number. So the only numbers that multiply to 7 are 1 and 7. And those two numbers, there's no way that they add to negative 2. There's no combination of them that do. So we've run into an issue here where we can't factor this. So does that mean it's just not solvable? Because I'm sure if we plugged this into Desmos or we tried to graph it, we would see an actual quadratic. Right? There's nothing wrong with this quadratic equation. It's very similar to what we've seen before. If we wanted to, we could tell that the y-intercept is -7. It opens up. We could complete the square as well to find our vertex form. And then if we really wanted to, we could then take that vertex form and solve for x like we did in example B. But that tends to be a lot of work, right? And we don't want to try to do too much work because then it just adds for more opportunity for small errors. So what we're going to do is use what we call the quadratic formula. And the quadratic formula works when an equation is in standard form, or basically ax squared plus bx plus c, and we usually tend to set it equal to 0 because we're trying to solve for when y equals 0. The quadratic form can be used, or the formula can be used. And they can be used whether you can factor that standard form or not. So if you think back to the last lesson where we had that one-word problem with ridiculously big numbers, even though we factored it, we can use the quadratic formula to get our two factors. And that's probably going to be a little bit easier. So if you run across something, or even if you forget how to factor, you can always use the quadratic equation, and that will give you your solutions. So the quadratic equation, or the quadratic formula, is this formula right here. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. I know it sounds complicated, but it really just breaks down to just entering numbers and just calculating them. A, b, and c come from your standard form, that ax squared plus bx plus c. Those coefficients and constants, those are the values that you're plugging into this equation to solve for your solutions. Again, the plus or minus means that there are two answers. Similar to what we just talked about when you take the square root, we're accounting for that here by having the plus or minus whatever the square root is. So in this case, basically we're going to have one answer where we add the square root and one answer where we subtract the square root. Now again, you don't have to do two separate equations right at the beginning. I'll go through a couple examples and you'll see kind of when we start to apply that plus or minus. So let's go through, and we want to basically determine the roots using the quadratic formula. And we're going to express our answers as both exact roots and approximate roots. And again, I'll show you the difference between the two. So looking at this standard form, it helps to identify our a, b, and our c value, because then that allows us to easily plug them into our quadratic formula. So in this case, a is the first number. I don't see anything, so it's that invisible 1. B is 4, and C is -8. Again, make sure you take the sign in front of the term. Next, I'm going to write out my formula. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Again, you don't have to worry about memorizing this. Again, any assignment or culminating, you'll get your notes, even if on an exam, you would be given this formula anyways. Now that I have this formula, I'm going to plug in all my values. So the negative stays there no matter what. So negative, and then my b value of 4 plus or minus the square root of 4 squared minus 4 times 1 times -8, all divided by 2 times 1. Now I'm going to go through and simplify some things. So -4 plus or minus, I can do the 4 squared, which is 16, minus 4 times 1 times -8, or basically 4 times -8, -32, all divided by 2. and then x equals -4 plus or minus, I can simplify the square root. 16 plus 32 is 48, all divided by 2. Once we've simplified everything, this is now where we can split off into our two different solutions. One, we're going to have x equals -4 plus the square root of 48 divided by 2. And we're going to have x equals -4 minus the square root of 48 divided by 2. And this right here is what you would call your exact roots, because these are my exact solutions, right? I'm not rounding anything. This is exactly what my solutions are. When we take it a step further and actually solve this, actually let me rewrite this just to make it a little bit. We're going to have to do a little bit of solving here. So now when I go, so now this is basically, oops. So these two again, like I said, are my exact roots. And when I go through and simplify, x equals -4 plus, now we can just figure out the square root of 48 is 6.93, all divided by 2. X equals, and we can do the same thing for the bottom one, x equals -48 minus 6.93 divided by 2. We get x equals, so -4 plus 6.93 divided by 2, 1.465. So there's one solution. And if we do the same thing, -4 minus 6.93 divided by 2, we get -5.465. So we have our two exact roots or exact answers, the ones where we haven't done the square root yet. And then we have our two approximate solutions or approximate roots. So both are essentially the same thing. One's just approximate because, again, with those decimals, they can go on forever. Or with those roots, when we find those roots, they can go on forever. And without taking the square root, it's the exact value. So again, in most cases, I am going to ask you to find the exact solution. Example 2, again, same idea. Find your A, B, and C value. So our A value is the first one, our B is the second one, our C is the last one. Again, if you come across a situation where you tend to be missing a part or a term, you don't just rearrange the values to make them fit, right? The A is in front of the x squared, the B is in front of the x, the C is on its own. If you're missing one of those terms, then you have to assume that the A, B, or C will be 0. Because again, that's the only thing that you don't have to show. And for A and B, if it was 0, 0 times x squared or 0 times x is just 0, so it disappears. So if we don't see a spot, we have to put in a 0 for that value. So our A value is 3, our B value is -4, and our C value is 1. So I'm not going to worry about factoring this. I'm just going to go right to the quadratic formula. I don't even want to worry about factoring. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. I'm going to plug in my values. So negative b, so negative 4 plus or minus negative 4 squared minus 4 times 3 times 1, all divided by 2 times 3. I'm going to work on simplifying some things. Negative 4 is just positive 4, plus or minus the square root of 16, minus 4 times 3 times 1, which is 12, divided by 6. Again, I can keep on simplifying this. X equals 4 plus or minus the square root of 4, all divided by 6. Here, we don't really have to worry too much about our exact roots because we do get a nice square root here. So again, I can simplify this a bit further. X equals 4 plus or minus 2 divided by 6. And then from here, again, now we can break off into our two parts to do the plus or minus. So one will be x equals 4 plus 2 divided by 6, and one will be x equals 4 minus 2 divided by 6. In this case, 6 over 6, or 1, 2 over 6, or 1/3. So that means these are my two solutions, or my two x-intercepts for this quadratic equation. So I'm not going to do too many more examples with quadratic formula because again, it's just plugging in the values into the formula and calculating them. Just be careful with the negatives. Make sure you're doing your BEDMAS properly. Make sure you're entering it into your calculator properly. When you're dealing with negatives and the exponents, put brackets around the negative to make sure it's included. Right? Just the simple things or the common things that we've talked about in the past in terms of solving or using or doing calculations. What we're going to look at here is we're going to look at situations or kind of word problems. And there's things that we've kind of seen before, but now we're going to use the quadratic formula to solve them. So for the first one, the length of a photograph is 1 centimeter more than its width. If the area is 45 centimeters squared, determine the dimensions of the photograph, correct to 2 decimal places. So if this is my photograph here, I think in the notes there may be an actual picture, so let's just draw one here. So the dimensions of this picture, we have our width, let's call x, and the length, or that's not, again, it doesn't really matter in this case, but let's say our width is x, and our length is going to be 1 centimeter more, or x plus 1. Now, if we don't know where to start, at least we know we're talking about area. And if we're talking about area in a rectangle, area equals length times width. So now let's plug in what I know. I know that the area is 45, I know that the length is x plus 1, and I know the width is x. Similar, we've seen questions like this. I need to get this into standard form, set equal to 0, before I can even solve for x. So what I want to do is I want to expand the one side by distributing this x through to both terms. So x times x is x squared, x times 1 is 1x. If I want to move the 45 over, 0 gets left as a placeholder, x squared plus 1x minus 45. Now looking at this, I could try to factor it, but chances are there may not be a factor that, or two factors that multiply to negative 45 and add to 1. So let's use our quadratic formula. So again, we may want to just write down our a, b, and our c value. Our a value in front of the x squared is 1, our b value is also 1, and our c value is negative 45. So in this case then, we get x equals negative b plus or minus the square root of 4, of b squared minus 4ac, all divided by 2a. X equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 45, all divided by 2 times 1. If we simplify it, negative 1 plus or minus 1 minus, so 4 times 1 is 4, times negative 45, negative 180, all divided by 2. X equals negative 1 plus or minus square root of 181, all divided by 2. Here, I can split it off into two parts. X equals negative 1 plus the square root of 181 divided by 2, and x equals negative 1 minus the square root of 181 divided by 2. Right off the bat, I can already see that I don't need to worry about this second one, because if I have a negative value and I'm already subtracting from that, that means my value is just going to get more negative. And if I look back at the scenario, a negative x value or a negative dimension doesn't make sense in this case. I'm still going to go through and solve for it, but in the end, I'm not going to end up using that answer. So if I go through and simplify, negative 1 plus the square root of 181 divided by 2, I should get 6.23 rounded. And with my second example, or the second solution, negative 1 minus the square root of 181 divided by 2, I get negative 7.23. So again, these are my two solutions. But looking at them, the one solution doesn't make sense, so I'm going to ignore it. So then that means, in terms of my actual scenario, my two dimensions, one is x and one is x plus 1. So my one dimension is 6.23 centimeters, and my other dimension is 6.23 plus 1, or 7.23 centimeters. So these are my two dimensions for this photograph. And again, we just got that from using our area formula to come up with a standard form equation, plugging those values into our quadratic formula, solving, choosing the correct solution, or the right, or the realistic solution, you could say, and then plugging that back in for the dimensions. Example, or the next example, again, there's two problems to this. Both are going to involve the quadratic formula. So again, this is going to be more about not so much using the quadratic formula, but just understanding what is being asked in the question and how to solve a similar question. So a trained stunt diver is diving off of a platform that is 15 meters high into a pool of water that is 45 centimeters deep. The height h in meters of the stunt diver above the water is modeled by h equals negative 4.9 t plus 1.2 t plus 15, where t is the start, or is the time in seconds after starting the dive. Part A is asking us how long is the stunt diver above 15 meters, and part B is asking us how long is the stunt diver in the air. So there's two situations here. The first one, how long is the stunt diver above 15 meters, and B, how long is he in the air? So if we're looking at, say, a graph, right, so we're at the diving board. That's 15 meters above the pool. Our diver is going to dive off, come back down, and hit the water or hit the pool. So the one part is asking how long is he in the air or above 15 meters. So because it's a parabola or quadratic, we know that it's going to hit 15 meters twice. Right? So we're looking for the first part, how long or what is that distance or that time when he starts to when he hits 15 meters again. And the second part is asking how long is he in the air. So we're looking at this overall part to down here, or basically when does he hit the bottom, or when does his height equal 0. So there's two things here that we have to do. The first one, we're looking for when h equals 15, and the second one, we're looking for when h equals 0. So we're going to have to do two different quadratic formulas, because in part A, if I plug 15 in for h and negative 4.9 t plus 1.2 t plus 15, I need to rearrange this and rearrange this into standard form. So the 15 has to move over to the other side, so I get 0 equals negative 4.9 t, t squared, plus 1.2 t, plus, move the 15 over, it becomes minus 15, so basically just cancels that out. Now I need to find my a, b, and c value and plug it into my quadratic formula. So a in this case is negative 4.9, b is 1.2, and c equals 0. So these are my three values that I'm going to be using in my quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2. X equals negative 1.2 plus or minus 1.2 squared minus 4 times negative 4.9 times 0, 2a, all divided by 2 times negative 4.9. X equals negative 1.2 plus or minus, really I only need to worry about the 1.2 squared because everything else just turns to 0. And if I take the square root of 1.2, so for example 1.2 squared is 1.44, but when I take the square root of that, I just work back to 1.2 because that squared and the square root cancel out. And I simplify the bottom, 2 times negative 4.9, negative 9.8. Now I can break this off into two parts to find my two solutions, right? Because again, I should be having 2 points when when the height is 15. So the first one, x equals negative 1.2 plus 1.2 divided by negative 9.8. In this case, negative 1.2 plus 1.2 is 0. So 0 divided by negative 9.8 is just 0. Which makes sense because we know that when time equals 0, the height is 15. Because we know that's where he's starting from. That's his starting platform. So the second value, negative 1.2 minus 1.2 divided by negative 9.8. Again, I'm just going to do this calculation all at once. And I get x equals 0.24. So that means that he hits 15 meters at 0, and again continues up, and then hits it again on the way down at 0.24. So that means for A, therefore he is above 15 meters for 0.24 seconds. Okay, because again, if we go back to this graph here, starts here, jumps up, then 0.24 seconds later, he's hit 15 meters on the way down. So that's that total distance. For B, how long is he in the air for? Well, now we're going to do the same thing, except now we're looking for when does his height equal 0, because that will tell us that farthest distance. So instead of h, we're going to have 0, negative 4.9 t squared, plus 1.2 t, plus 15. I don't need to rearrange anything here. So my A, B, and C value I can get just from this form. So A is negative 4.9, B is 1.2, and C is 15. So we are going to have to do a little bit more calculations because we don't have that 0 to kind of cancel some things out. Let me just move that out of the way. So using my quadratic formula now, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. X equals negative 1.2 plus or minus the square root of 1.2 squared minus 4 times negative 4.9 times 15. Again, just plugging all those values in. Nothing fancy, just plugging the values in. All divided by 2 times negative 4.9. X equals negative 1.2 plus or minus 1.2 squared was 1.44. Got that from the last one. And then minus 4 times negative 4.9 times 15 minus negative 294, all divided by negative 9.8. And finally, I'm going to simplify the square root, so negative 1.2 plus or minus the square root of 1.44 plus 294, 295.44, all divided by negative 9.8. Now I can break this off into my two parts with the plus or minus. So I'm going to have x equals negative 1.2 plus the square root of 295.44 divided by negative 9.8, and x equals negative 1.2 minus the square root of 295.44 divided by negative 9.8. You might be able to recognize that in the first one, I'm going to get a positive divided by a negative, so I don't have to, which will leave me with a negative x value, which doesn't quite make sense in this scenario. So we could just ignore that one and move and just focus on the second one. So when I simplify this, negative 1.2 minus the square root 295.44 divided by negative 9.8. I get 1.88. And just for the sake of argument, if I do the same thing with the second one, (295.44) divided by negative 9.8, I get negative 1.63. Again, going back to our graph, it doesn't quite make sense in terms of the context to have a negative time, so I'm going to ignore the second one. It's not realistic based on the scenario. So that means the only other time that the height is 0 is at 1.88 seconds. So that means that therefore he is in the air for 1.88 seconds, because we know the time is starting from 0. So again, long calculations, but hopefully if we're comfortable with our calculators or comfortable doing calculations, they're fairly straightforward. I'd say the biggest issue will be, again, just doing the calculations, making sure we're getting the right A, B, and C value. For some of these word contexts or word situations, make sure we're entering the right values, then rearranging them if necessary to get it into standard form. And again, look at the scenario, look at the context, so that when you look at your final solutions, you get an idea or you understand which answers or which solutions you're looking at.